is called almost sorted. So the problem statement says that we are given an array of integers and you have to determine whether the array can be made into ascending order using only one of the two operations, and only once. The two operations are either swapping the two elements or reversing one subsegment. So either suppose we have 1, 2, 3, we can either swap 2 and 3, make it 1, 3, 2, or reversing a subsegment. So suppose we have an array 1, 2, 5, 4, 3. We can reverse 5, 4, 3 and make it 1, 2, 3, 4, 5. So those are the summary of the two operations. We have to determine whether we can perform either one of those operations and make our array into an ascending order. So I've prepared some examples over here. Can you all tell me what the output should be for this? Means whether this can be made into ascending order by one of the operations or no. Take a try, like very easy questions. But can someone unmute and answer?
I guess we could swap 3 and 4.
Yes, so we can swap 3 and 4. And since the question requires indexes and we're using zero-based indexing, we'll put swap 2 and 3 over here. What about this case? Can we perform any one of the operations to get our array into ascending order? In this case, I do not think swapping will not be possible, but I think if we take this subarray and we reverse this subarray, this will become 4, 7, 7, 8, 9, 11, which is in ascending order. So we can use that operation. So we can, our output should be reverse 2, 5. So we can reverse all the elements starting from 2, ending at index 5. What about this? This is already sorted. So we can simply just print out yes, and that's it. Now this is the main case of the question. I'll already tell you this case, it is not possible. Why isn't it possible? Well, because 2, 4, 3, 6, 5 are currently, or actually 4, 3, 6, 5 currently aren't in the actual positions they need to be in. Ideally, our ascending order array would be 1, 2, 3, 4, 5, 6. But 4, 3, 6, 5 are out of order. We cannot rectify this by swapping any of the two elements. And we cannot even reverse this entire 4, 3, 6, 5 segment to get it into an ascending order. So clearly this should be no. So how would we go about this problem? Would we find out all the elements which are not in order? Would we find out all the subsegments which are not in order and try reversing them, try swapping all the elements and figuring it out? Clearly, it's not really possible to do that because we have constraints that are of quite the size. Like this is 1 million, so 10 raised to 6. We can max have an n log n solution or maybe an O of n solution if possible. So the key to this problem lies in figuring out what we need to check and which indices do we need to check between. So swapping is only possible when two and exactly two elements are out of their desired position. Like in case 1, 3 and 4 are out of the desired position. Rest all of the elements are exactly in the position they need to be in. So that is fine. We can swap elements and do it. What about case 2? In case 2, 11, 9, 8, 7 are all out of position. Swapping is not possible at all. So we need to reverse. Clearly, we need to reverse. But from where to where do we need to reverse? And how do we figure that out? Like clearly, by looking at it, we can say that, OK, these 4 we have to reverse. But how do we write code for it? So let's see. What if we were to reverse 11 and 9? Then maybe 4, 7, 9, 11 would be in an ascending order. But we would leave out these last two elements, which are still not in their ascending order. So if we want to get each and every index into the ascending order, it needs to be, the segment needs to be between the first index, which is not in its position, and the last index, which is not in its position. Because notice the problem mentions that we can have only one of these operations. It's not like we can take multiple subsegments of the array and then reverse them individually or something. It's one and only one operation. So we have to account for all of the indices which are not in the current order. So this has everyone understood the logic behind this? Uh,
Yes.
okay, so I'll move on to the code and you'll get a better understanding of what's happening over here. Let me just make this full screen. So this is a really fun implementation, makes a use of a lot of functions and algorithms from the standard template library in C++. This is why I like coding in C++. A lot of stuff is done for you without compromising too much on time. So if you all are coding in C++ and you all want to get better at it, I'd recommend studying up on the STL. So the first thing I'm checking if the array I'm given in means vector v is already sorted or not. The STL as an inbuilt function is sorted, which I can pass in the beginning as well as the end pointers of the vector to check if it is sorted or not. It returns either true or false depending on whether, like self-explanatory, sorted or not. If it is sorted, I'll output yes and I'll return. I do not need to check the rest of the conditions. I can return early and my code stops over here if the array is sorted. Otherwise, as I said, I need to find the first index, which is out of position, as well as the last index, which is out of position. How would I do that? So my approach would be to create a copy of the input vector and sort it. So this copy vector is what we want our array to look like ideally after performing the operation. That may it be swapping or reversing. I want my array after that operation to look like my copy array. And I can make use of this copy vector to find out which index is the first as well as the last index, which is out of place. So here, generally, I'm just declaring integer n to be equal to the size of the vector. I'm declaring an integer L. In this L, I'll store the first index, which is out of place. And this, to find this is really, really easy, a normal for loop. And for the first position, where my input vector is not equal to the output, is equal to the copy vector, which is sorted in ascending order, I'll set my L to that index and I'll break. Similarly, I'll do this from the end, I equals to n minus 1, I minus minus, and this gives me L and R, which is the first as well as the last index. So over here, what will L and R be in this test case 2? Does anyone want to give it a shot? So if I start from here, my sorted array would actually be 4, 7, 7, 8, 9, and 11. So 4 and 4 is matching, that's fine. 7 and 7 is matching. 7 and 11 is not matching. So I equals to 2, I would set L equals to 2, and I would break out of this loop. Now my second loop would run from the end. And okay, at the first index itself, 11 is not equal to 7. So I'll set my R equals to 5. So I have L as the first index where it's not matching and R as the last index where it's not matching. And notice the order given in the question. We first have to check whether swapping is possible or not to convert it into an ascending order vector. So I swap the first and the last index. If after swapping these indices, if the array is sorted, I can output yes as well as swap and the indexes and return. End of my code. I found the solution. That's it. But then if that is not the case, this if loop will not be executed, this if statement will not be executed, and I will reswap back my elements. This is really important. Otherwise, you'll keep getting errors because we need our array restored to what it originally was. Now, as I said before, we need to reverse each and every element which is not in its correct order. We cannot pick up a smaller subsegment because then it will be guaranteed that that array is not in ascending order. So we reverse again using a function from the standard template library. We reverse the array indices beginning from L and ending at R. This R plus 1 because we need to give the index after the index we want to reverse till. And now, once again, for the final time, I check if the vector is sorted or not. If it is, I output reverse L plus 1, R plus 1, and I return. Otherwise, I output no. So that was the solution for problem 2 of day 4, almost sorted. Does anyone have any doubts with regards to the explanation, implementation, any other alternative approaches you all would want to discuss?
Feel free to ask doubts, guys. This session is for y'all, right? So any doubt that you guys have, right? If you are feeling it hard, you can are not able to understand, do let us know, right? We want to help you out.
If you all do not want to speak it out loud, you all can put it on the chat too. We'll move on to the next problem in a minute. Okay, so we'll move on to problem 1, save the prisoner. How many people could solve this problem? It was a really easy problem to solve. Just some mathematical analysis and you would have gotten it. Implementation was the easiest so far. Just 2 lines of code actually. Okay, let's go to the problem. I'll explain you the problem statement in short. It says that there's a prisoner in a jail who's handing out candies to prisoners sequentially. There are n prisoners. He has m candies to hand out, and he starts handing out candies from prisoner S. So suppose, and he has to find, and we have to find out who is the last prisoner to get the candy. Let's just go over a quick test case so you'll understand it better. I'll just take this test case. N equals to 4, implying that there are 4 prisoners. M equals to 6, indicating there are 6 candies to be distributed. And S equal to 2, implying that we are starting distribution from prisoner 2. So looking at this, what would your first thought be? How would I solve this problem? A lot of people would think, okay, let me just use a for loop for int I equals to 0, I less than s or s minus 1, I plus plus, I less than m or m minus 1 and I plus plus, and s plus equal to 1. And then if I reach the end of the array, I go back to the start. That would actually not work because of the constraints. The constraints say it is from 1 to 10 raised to 9. So in the worst case, there are 10 raised to 9 iterations of your for loop, which will give you a time limit exceeded. So always check the constraints first. I made this mistake. I didn't look at the constraints, implemented a for loop, passed the sample test cases, and then when I pressed submit, it of course failed. So clearly O of n also will not work. So we cannot even use a single loop. So we need to make some optimizations to minimize the number of operations we are performing. So this can be done with math. Some of you all might have noticed, okay, we do not actually need to run a for loop for all of this. We can directly just calculate where we end up at. And that's exactly what we are going to do. Let's take up a dry run first. So m was equal to what? M was 6, right? M equals to 6 and S was equal to 2. That means we were starting from position 2. So I'll hand out a candy to prisoner 2, prisoner 3, prisoner 4, prisoner 1. This is the 4th candy. Prisoner 2. This is the 5th candy. And prisoner 6. Prisoner 3. This is the 6th candy. So my answer should be 3. This is fine for small test cases. This logic everyone might have gotten. Give out candies in an order. If you reach, suppose you're iterating with the variable I. If you reach n, then loop back to 1 and start the process again. But this is not really possible for large inputs, as I said. So we need to make some observations. The first and the most important observation that we can make is after what amount of candy is given out, do we reach the same position again? So suppose I was giving out 4 candies because n equals to 4 in this case, we have 4 prisoners. I'm starting. I have to start. The first candy I have to give out to is a prisoner 2. So I give out a candy to prisoner 2. I give out a candy to prisoner 3. Give out a candy to prisoner 4. And I give out my last candy to prisoner 1. So notice that I'm back at 2. I started with having to give a candy to prisoner 2, and I ended also to having give a candy to prisoner 2. What if it was 2n, maybe 8? So again, 2, 3, 4, 1. We are back at 2. So no matter, we can make an observation. You can try it out for other values of n. A multiple of n candies are given out, we'll always end up back at the same position. So suppose over here I was giving out, say, 11 candies. So I could subtract 4 from it, get 7, subtract 4 from it again, and get 3. So giving out 11 candies is just the same as giving out 7 candies, which is again just the same as giving out 3 candies. But of course, again, 10 raised to 9. So even subtracting 4, 4, 5, 5 from 10 raised to 9 is really a tedious task, and it will give you a TLE again. So can anyone tell me what I can do to reduce these multiple subtraction operations into a single operation? Does anyone have a guess? Any idea on what operation, what operator will we use? So we'll be using the modulo operator, that is 11 modulo 4 equals to 3. So it's basically m modulo n. This is just the same thing as giving out m candies. Giving out m modulo n candies is the same thing as giving out m candies. That is the most important observation we need to make in this problem, and this will help us to solve the problem. Now it's just a matter of implementation. So how will I do this normally? Now, okay, I know m mod n candies are to be given out, and I know how to start from position s. So I can just write s plus m minus 1, s plus m minus 1 modulo n. So will this give me the right answer or no? Let's just try it out. For this case, we have s equals to 2. We are giving out how many candies? M equals to 6. So can anyone tell me why I have given this minus 1 over here? So this minus 1 was given out because I am starting from the position, but I have not yet given a candy to that position. So I'm starting with prisoner 2, but prisoner 2 is yet to receive a candy. So I have to subtract 1 and then move on. I cannot assume that prisoner 2 has been given a candy and then move on. So I'll subtract 1 from the total amount of candies which are to be given. And of course, this s plus m minus 1 is in a bracket, and that modulo n. So 2 plus 6 minus 1 mod n. So that will be 7 modulo 4, which is 3. We can test it out. 1, 2, 3, 4, 5, and 6. Okay, 6 indeed gives us 3 as the last prisoner to receive a candy. But still, this is not really correct because we are running into one issue. And that issue has to do with how modulo works. Modulo works optimally and works ideally for zero-based indexing, not really for one-based indexing. Suppose we had candies instead of 6, we had 7 candies to give out. Then this would become 8 modulo 4, and this would give us an answer as 0. But we do not have a prisoner who has a 0th prisoner, right? So this fails. So we just need to convert this into zero-based indexing. We can do that by doing an s minus 1. And after this operation is performed, we can increment it by 1. Or just a second, I'll write it a bit more clearly down here so you all can get a better idea. Or I'll type it out rather. Just a second. So I'm saying I'll do s minus 1. I'll put it in brackets. S minus 1 for zero-based indexing plus m minus 1 because I have to give out m minus 1 candies after prisoner s, and then modulo n, and then I'll add 1 to negate my zero-based indexing because this will give me an answer in zero-based index, but the question requires one-based indexing. So I'll add this 1 back in. This is to handle the edge case I just told you about where modulo n is coming as 0, which is not possible for us. So just like I told you, the code isn't really hard. It's a single line of code, just one single line of code, and this gives us a correct answer. It was all about figuring out what solution to use, figuring out that even an O of n solution, that is using a single for loop, is not feasible, and figuring out what operations should I perform to minimize the number of steps I have to take. So that was the problem. It was a really easy problem. I hope you all try it out once again. The implementation isn't hard, but this logic is really, really important and used in a lot of problems like circular arrays or stuff like that. So please do give it a try again later. If you all have any doubts, please ask about the problem implementation. Not really about the implementation. There isn't really much to discuss about that. But yes, does anyone have any doubts?
Okay, I have a doubt. How does how like I am unable to think of how you uh, converted the consecutive subtractions to modular, right? Because it's not intuitive to me. I'm not able to think how.
So you can think of division as consecutive subtractions until we require a quotient and a remainder. So that is a fundamental thing of division. Suppose I want to divide 16 by 5. This everyone intuitively knows it's okay, 3.2 or 3/1/5. But how did we arrive at this answer? Well, it's just 16 minus 5. Let me just type it out. I have a pain writing this stuff down. So it's just 16 minus 5, that's equal to 11. So our quotient currently is 1 because we subtracted it from it once. Now we have 11. We'll subtract 5 from it again. This is equal to 6. And our quotient is 2. So we have 6 again. 6 minus 5 equals to 1. Quotient is 3, and we cannot do this any further. So we got a quotient by subtracting. Our quotient is basically how many times we can subtract our divisor from the dividend without getting a negative number. But what is the remainder? The remainder is, suppose we are dividing a by b. Our divisor and b and x, let x be the number of times we are subtracting without it becoming negative. So my remainder is nothing but a minus x times b, correct?
Yes,
And that can be simply done by the modular operator. Our modular operator will give us the remainder which we need. So as I proved to you above that repeated operations and repeated operations mean nothing. They discard each other. They negate each other. So instead of subtracting 5 over and over again, we can use the division operation. And from the division operation, we do not really need the quotient. What we really need is the remainder. So for that, we use the modulo operator, which gives us the remainder.
makes sense. Thanks a lot.
No problem. So now we'll move on to problem 3. Problem 3 was a tricky, really tricky problem for those who haven't done recursion or dynamic programming. But let's not get intimidated by it. Let's just take a look at the problem statement. Out of all of the 3 problem statements, this was probably the easiest to understand and the quickest to go through. We are given an amount. So suppose over here they have mentioned n equals to 3, and we have an array of coins. We have to determine how many ways we can use the coins given in that array to get the sum required. So using coins 8, 3, 1, 2, how many sets can we make to get n equals to 3? So this we go through, we can do by recursion. Let's forget about the dynamic programming DP part for it right now. Let's just treat it like a purely recursive problem. How would we do this by recursion? Actually, before that, what is recursion? Can someone tell me what recursion is? So recursion is basically solving a big problem by dividing it into smaller and smaller sub-problems until we arrive upon a small enough sub-problem that we know an answer to. A lot of y'all might have done recursion. We do it in the first year, solve some problems recursively, like some of y'all might have done factorial recursively, maybe some of all natural numbers till n recursively. If y'all have explored a little more, maybe y'all have done Fibonacci series using recursion or towers of Hanoi or some other problem. So in that, you'll know the structure. We have a recursive function which keeps calling itself until we reach a base case to which we know a solution and we return an answer to. So over here, what would be smaller subproblems? That n is too small. Let's go to this sample input and tell me. My original problem is I have 10, let's just say rupees. I have 10 rupees I want to give out. And I have coins of 2 rupees, 5 rupees, 3 rupees, and 6 rupees. So how can I add them up to get 10 rupees? So what is the recursive part in this? How can I write my function recursively? What parameters will my function take? And what will be the smaller and smaller subproblems? So the thing to notice here is that the solution for n equals to 10 and this array is the number of ways we can give a change of 10, give a sum of 10 rupees is just the way we can give a sum of 8 rupees plus 5 rupees plus 7 rupees plus 4 rupees, the number of ways, right? Because we can use the 2 coin and then we'll arrive at having to give 8 rupees. We can use the 5 rupee coin and now arrive at the problem of having to give 5 rupees. Then I'll come at the 3 rupee coin and of course, okay, now I need to give 7 rupees and similarly for 6 and 4. So this is a smaller and smaller subproblem. Now for 8, we go on till 6 and we go on to 3 and 2 more subcases which are not written down. And then finally for 6, the 4 subcases, I've taken 1 where I can use a 6 rupee coin and now I come to 0. In this case, you can see I found a solution. I can use a 2 rupee coin to go from 10 to 8. I can use a 2 rupee coin again to go from 8 to 6. And I can use a 6 rupee coin to go from 6 to 0. And now my 6 plus 2 is the exact 10 that I need. So this is a valid solution. So this is my base case. If n equals to 0, return 1. So return 1 indicates I have reached a valid solution. Okay, what about this path? After I reached 8 by taking a 2 rupee coin, I take a 5 rupee coin to reach 3 and I take a 5 rupee coin again. But now I've reached -2. This is not what I wanted. I wanted exactly 10. But this is -2. This is not a valid way. I cannot subtract money anyhow. So any further addition would also be pointless. I'll return 0, indicating there is no way from this line of functions, there is no way to find a valid solution. So I return 0. But you all have noticed just for a single or uh, two lines of what do you say function calls, there are these many calls. So this is very inefficient because I'm calling the same values over and over again, over and over again. I haven't really made the tree, but you'll notice that, okay, for 6, maybe I'll be calling 6 somewhere else also. Over here, suppose I take a 2 and I'll reach this 3 again, which means I'm making the same call again and again. So don't you think it would be better to store the results I have already calculated somewhere? So that is what dynamic programming is. Once we calculate a certain value, we store that value in an array. And then every time we come across that value again, we do not need to make so many more recursive calls. We can simply look it up in our DP table. The structure we use is called a DP table. It can be an array, a vector, a hash map, whatever you want. It's called a DP table. We look up the current states we are in our DP table, And if we see we have already calculated the value for this, then we return that value. Otherwise, okay, we go on with a normal recursive calculation. So that's the logic. Please stop me and ask if you haven't understood some part of this. If you are newly introduced to DP, you will be having some doubts about this. So please feel free to ask. No doubts. Wow.
Yeah, can you just repeat the logic once?
The last part. Hello.
Yes, the last part.
Okay, so in the last part,
Yeah,
I discussed about DP. So what I said in DP is like in recursion, we make repeated calls over and over again, duplicate calls, calls we have already computed before. Because in recursion, first this path will be calculated, then maybe this part, then all of the parts of 6 will be calculated, then maybe all of the parts of 8 will be calculated. The leftmost calls are calculated first, and then we move upwards. Then we'll move to 5. Then after computing all of 5's calls, we move to 7. But we'll be making a lot of duplicate calls we have already come across before, and it's wasting a lot of time recomputing those values. So wouldn't it just be efficient to keep track of the values we've already stored in a table, like it's called a table. You can store it in an array, you can store it in a vector, maybe in a hash map, whichever structure, dictionary if you use Python. So yes, that's what dynamic programming is. Reducing your number of function calls by storing the values you have already calculated. Did you get it?
yeah, thanks.
No problem. So let's go into the implementation. The main thing is like over here, I've declared my own function. We told you not to code outside of this function in HackerRank, but if you want to use a recursive function or something, you need to declare your own function. So I've declared a function over here. I called it func. I've taken an integer n. This n is the amount of change I need to get right now. So at the start, it will be whatever is passed in by the value, suppose 10. And then later, when I'm making more and more calls, I'll keep decreasing and decreasing. This vector is also taken from the input only. It's the coin values which we are provided. This this is the DP table. So the DP table has two states currently. So what are states? States are basically the current condition of my call. So suppose I'm calculating. So let me just explain it to you with one state right now. Suppose I have calculated the value, the number of ways I can get 5 coins, get coins equal to 5 already. I store it in DP of 5. So I'll just write it down over here to give you a better understanding. Suppose I can get 5 in 9 different ways. So I'll just store DP of 5 equals to 9. But over here, if you've noticed, I've not used a single state. I've used two states. And I'll get to why I've done that later. But this is the DP table which I was mentioning. I've implemented it as a vector of vectors. If you're programming it in C, maybe you can just use simple arrays and integer x. I'll get to what this x is to in a bit. As I explained before, if n equals to 0, return 1. If n less than 0, return 0. N equals to 0 indicates this is a valid solution. So I found one valid solution, so I'll return 1. If I go under 0, that means I get a negative amount of coins. I'll return 0, indicating, okay, this has gone too far. I'm not getting a solution past this, and this is not also not a valid solution for me. So just return 0. No point checking this any further. And this is the main part of DP. I check in my DP table if I have a value or not equal to -1. Originally, when I'm declaring my DP vector, DP table, I initialize all the values of that to -1. Why -1? No reason in particular. It's just that I can never have -1 as an actual value, right? Number of ways can only be between 0 to whatever, how many ever ways there are. It can never be -1 ways to get to 10 coins, right? So I just store it as -1 as an indicator that no, I haven't computed this value before. So that is what I have stored -1 for. When my value gets updated, suppose dp5 equals to 9, and I come across in 10 equals to 5 again, this condition will see, okay, dp of 5 is not -1. So I'll return dp of 5. So if that is not the case, I declare a variable sum. This sum is just the number of ways. What I need to find, number of ways I can get to n. And as I discussed, the number of ways I can get to n is nothing but I go through each coin and subtract that from my current total and make a function call for that. So for 10, I'll run a loop to the index. So this will be a function call for 8. So I'll add the number of ways I can get 8 into the sum. Then 10 minus 5. So number of ways I can get 5 into this sum. 10 minus 3, number of ways I can get 7 into this sum, and 10 minus 6. So number of ways I can get 4 into this sum. So all of these values will be added into my variable sum. And at the end, I'll return this sum. This is basically just shorthand for writing two things together. To make my DP table work, of course, I can write DP. I have to set my value in the DP table equal to that, right? I can write it like this too. It means the same thing. I normally write it like this. So yeah, you can do it this way too, if this makes more sense to look at. So I set my value of the DP table equals to sum and I return the sum. In my function that was provided, I simply declare my DP table. Over here 255 because, well, let's look at the constraints. My n can be 1 to 250, and just to account for some overflow, I've just given in 5 more spaces just so I don't accidentally cause some overflow. 1 or 2 will also be more than enough, but 5 just to be safe. And similarly, okay, before I explain that, let me just explain what this x is. If I didn't have this x, if I started with 0 and every time I just ran my function from 0, suppose over here, after picking 2, I picked 6, then I picked 2 again, and then 2 again. So that would be a valid solution to, okay, actually just 2 plus 6 plus 2. But then I would also get a function call for 2, 2, 6, right? So that would not really be possible because they are not unique solutions. 226 and 262 should be counted as the same solution only. But in my code, they will be counted for two different solutions. And that will give me a wrong answer. So I need to make sure that I'm not going backwards into my array. So if I've already come to say I've taken coin 3, I shouldn't really backtrack to and go to coin 2 because that has already been computed in previous computations, and going back will give me duplicate answers which will make my code fail. It'll give me much more answers than are actually real. So this x basically stores the index that I am currently at, and I start my loop with I equals to x. So I'll check elements only further than x. I will not check elements before x. And since I have this x, I need to even make it a state in my DP table. State as in something to check for. So over here I mentioned DP of 5. So DP of 5 is not really the same as DP of what do you say? DP of 5 and 0 isn't really the same as DP of 5 and 2. These two will be different values. So to make sure that they are different values stored in my DP table, I have to add another state to account for the differences. DP50, DP51 means I'm at index, whatever index I'm at currently. This is basically to avoid duplicate solutions. If you did not include this state, you would count 226 as a unique solution. 262 also would be counted. 622 would also be counted, and any other permutation would be also counted. But this we do not need to see. We only need to see combinations. Order does not matter to us. So to account for this ordering issue, I have declared another variable. So that was the code for problem 3. You all might be having some doubts on maybe what the DP table is or anything. So please feel free to ask. No one? Nothing?
Yeah, this one tough, but we'll still try to figure it out once more.
Okay.
Okay, yeah, sure. If you cannot figure it out or something, feel free to ask on the group. We'll be willing to help. And so
Yeah,
this is
definitely.
yeah. So this is DP or dynamic programming. It's a very important topic which is used in a lot of problems. So do practice it. Maybe start with more basic problems. Like a really famous one is Fibonacci series using dynamic programming. So try that out. Get more and more accustomed to it because it will really be a very valuable tool in your toolbox. Does anyone
For
else
people,
have any other doubts? Yeah, got it.
yeah. So for people who are like getting intimidated by what is dynamic programming, think of it like this, right? If you are given a task, let's say I tell you to calculate something like 100 plus 200 plus 300, right? So you will tell me, okay, it's 600. I'll tell you do it again. Okay, you'll do it again. I'll tell you like this 100 times. Are you going to calculate this 100 times? No, right? Once you've calculated it, if I ask you what is 100 plus 200 plus 300, you're just going to look at what you've calculated and tell me, right? You're reducing our work. And that is essentially the essence of programming. We just store it. Like if you have done dev, we just store it in a kind of database of whatever we have calculated. And whenever we need the solution for a particular sub problem, we just check has it been calculated. If it has been calculated, we just use that answer. We don't calculate it again, right? But if it has not been calculated, then calculate. And
So yes, this was the 3 problems for today. These 2 days, the weekend, we won't be sending any problems. You will be free to cover up on the problems you missed, maybe re-implement some of the harder problems, some new concepts you had come across. We'll be starting with the Striver sheet on Monday. So get pumped, revise all your concepts. If you're doing C++, go through the HTL. And please ask some doubts in the group if you run into any. It need not be of problems from the Striver sheet or the problems we are coming. Any DSA related queries will be entertained and there'll be people willing to help you. So yes, that's it for today. Thank you all for attending. Does anyone else have anything to say before we end the meet? Okay, then I guess we'll end the meet. Thank you all for attending.
Bye bye. Thank you.
Thank you.
Thank you. Bye.